Hey guys, today's video is going to be on this. This is a BykSki case wall test bench. Now, as you'll see for the rest of the video, when I'm putting this together, the motherboard is different. I'm adding this part a little bit into the front of the video because I changed the platform and I got the Threadripper 9000 series chip as I was putting this together. So with that said, let's get started. Now, I want to say that BykSki sent me this wall case along with some of the other stuff. So it might be packaged a little differently for when you purchase it, but the pumps that come with this case wall, they do not come packaged in one box. They're going to come separately. I haven't opened those really, so we're going to take a look at them. This I've opened before, but I didn't really fully assemble it. So you're going to see that some parts are slightly missing, of course, but it comes flat pack like this. With nice foam, and each layer you're going to have different parts. Like this layer has the radiator, right? The radiator brackets. And then if you open, well, here's some of the hardware. And then the next layer is going to have some of the other componentry. Like here we have the motherboard tray. I don't think this was loose before. I think it's because I moved it out of the way. The reason why this took me so long, because I got this about a year ago, to get to it was because I kind of forgot about it. And at the same time, it took me some time to get around to doing this. But this is the base and the main primary pillar. All right, these parts are all aluminum anodized, and this is heavy. This is like high quality, aluminum and so forth. But you'll see at the bottom, this is silver because I had to actually sand it. All right, it actually came out. This is part of the base, not the full base. It actually came out an extra about 3 millimeters. That might be a QC thing. I did mention it to BykSki. They never got back to me, so I guess maybe it was just mine. Because I thought, how could you be off by 3 millimeters? Because that's a lot, right? But actually, yeah, because what happens is this screw hole, which has an Allen bolt that goes through it to connect to this pillar, doesn't fit if you were to have this flush, because there's another base that comes on. When I install that base, you guys will see it. But there's another base that comes onto here, and because it was sticking out so much, there was no way for me to stick that bolt in. So I came to the conclusion that it was just actually 3 millimeters too long. And I ended up just, using an air grinder, just sanding it off. All right? Grinding it off. But yeah, so that's pretty much how it comes packaged. I'm going to show you guys how it looks kind of assembled along the way. And we're going to tackle it like that. So this is the entire base. This structure, as you can tell, if I had not sanded the 3 millimeters off from this piece, it would not fit onto the main primary flat base at the bottom. That is the oversight that I was talking about earlier. This is very sturdy. It's very hefty. It's pretty heavy too, just because you kind of have to support the whole computer from flopping left to right. At this point, I'm going to then move on to the I think this is the radiator side, obviously, and then I'll do the motherboard side. I think this is about 6 millimeter aluminum. All of it is very thick aluminum, so it's definitely there in terms of pricing. I forgot to mention, guys, this thing's like $1,500, but it comes with the 2 pumps and stuff, which we'll look at in a bit. It does not come with instructions in the box, but there are assembly photos online. But given the price point, they really should include like an instruction booklet. But it's very typical of BykSki to not have instructions inside. Just like their blocks, there's no instructions. Nothing from BykSki ever comes with instructions. You just kind of refer to pictures online. And sometimes it's not nice when it comes to thermal pads where you kind of have to guess because they might just give you a bunch and then you have to figure it out. Here we have the radiator base, which is also the pump res base attached to the case. Well, case stand. I did forget to mention earlier that you get 4 radiator brackets. A set of them will be 480, like this one. Once again, 6 millimeter aluminum. And then you get another set for 360. What you do is you mount the radiator onto the bracket, and then you mount the bracket onto the frame. Okay, so that's kind of how it works. The reason you kind of have to stop here is because the screws to mount the 2 pump reses have to go through here, and then the motherboard tray overlaps it, so you have to mount it first. All right, I was hoping that I could do this last, but I'll just quickly show you guys what the 2 that come with, and then we'll continue moving forward. You get 2 pump reses. This is the D5 one. This is the DDC one. I'm not sure why they give you one of each and not just 2 DDCs or 2 D5s. I guess if you wanted to try I can't even, I guess, I don't know. I really don't understand why they would do that. But they don't let you get to choose. You just kind of get what you get. So even on the online website, you see that, they show one D5, one DDC. When I first initially made a parts list for BykSki, because they reached out at that point and said, hey, would you want to check out some of our stuff? I said, sure. And then they said, oh, just send over a part list. I actually had marked for 2 D5s because these things have their own part numbers. So you can actually see it. Yeah. And I think you can buy them on their own. But they told me, oh, you don't need to pick pumps for this case wall. It comes with the pumps. And I said, okay, does it come with 2 of the same pumps, or does the photos just show the options I can have? And they said, oh, no, don't worry about it. Everything's in there. You can just put it down and we'll get it to you. I said, okay. So when it came, I actually did get 1 D5 and 1 DDC. And that's how I see on the final retail as well. So I'm assuming that's what you're going to get. You can see here you get, once again, BykSki doesn't include instructions. So one of these, this probably is the in. This is in for the res. I'm going to guess one of these is out. Well, I have to find out. This is probably a drain. Right? They might have some on the assembly instructions, but it's all acetal, D5 pump, Molex with a PWM, and a Molex splitter. I kind of wish... I guess, why is there one going here? There's probably RGB in here. That's probably why there's a Molex here as well. I kind of wish they would use a SATA pump, but I guess this allows for sleeving. And you also, let's take a look at the DDC one. Let's see here. Okay. Nothing else. Just, they always include a QC sticker. That's about it. And yeah, like I said, BykSki keeps it really lean with the product documentation. Okay. So here you have another aluminum plate. This is the thing with BykSki I'm always talking about, is that things will be nice in terms of the machining work and the quality is not bad. But like along this top of this case here and all these parts, there's always some like residue. Like I've never taken this out and you can see there's residue on it. It's like sticky residue from just maybe the plastic that was here before, just stuff like that. Right, some things like that. This is probably the same pump they use on all the... Well, this SATA pump... Is this SATA? Oh, no, that's actually Molex. But this is unpluggable. It should be. Well, not this model? Okay. But this is your stand... This is not one of those 3.2 DDCs, I don't think. This you'll see on a lot of those like Iceman Cooler or Barrow, the pump reses. These are not like the 3.2 DDC. I don't believe they are. They're kind of another version. I think BitsPower calls them K1s or something like that. But it's definitely common in a lot of kind of reservoir combos. So this is kind of what you get here. And let's see, does it actually say it was 3.2 GDC? It does not say anything about that. It just says this product is a pump manufactured by BykSki. Here you can see the back view. I have both sides on now. The pumps and so forth on the other side, but I just wanted to show you the PSU side real quick. You can see that there is a bracket. On top of this, I have a 1600 watt Thor 3, and there's no sag whatsoever. So if it can hold this, it can hold pretty much anything. And here you have cutouts, you can tell already, for pass through the wires. Although they seem to be kind of slim, so custom cables might be a little challenging, right? There's obviously none for the 8-pin. There's a power switch hole here, which I don't think I'm going to use. And I think for most people with an open case, if you're spending $1,500 on a case, your motherboard probably has a power button on it. Okay? So let me just swap over to the other side of it. Here's the front view. You can tell that I've mounted the pump reses. Obviously, you can put the DDC on top if you choose to. I just put the D5 on top. But it's about 1,024 millimeters end to end on the long side. This is about 324 millimeters tall on this bracket. So it's not really that tall, but the width is there. So it's almost kind of like having an ultra wide monitor, I guess. But there's no VESA mount because it's kind of heavy and it's not designed to be VESA mounted given the base. So they've included this acrylic divider that actually has some laser cut on there saying that this is for this case. It's not a generic product. And it's supposed to hang here like that. Right? And that's supposed to give a divide between, I guess, motherboard and the rest, which doesn't really serve a purpose in my opinion, because it actually looks kind of dorky, but it actually looks better without it. But I guess if you wanted to hang that there, you could. I guess you could actually probably drill this into pass-throughs depending on how you mount your GPU, but I highly doubt that. Because there's no vertical mounting by default. You have to kind of use an adapter bracket, and it might still get in the way. So I'm not too sure why that's there. But let's put some hardware on here now just to kind of see how it looks. So some more issues. This PCI bracket was actually not in the box. The one I'm using here is from their BykSki test bench. Based on the way the holes line up, it's the exact same bracket from what I can tell. And from the photos, which aren't really high res, but it looks to be. So I took the one from my test bench, the BykSki test bench, which I did a video on before, and then I installed it onto here just so we can get things going. I let them know that that was missing in the box. I flipped through the entire box again because there's a lot of foam. It's just not in there. Additionally, back to what I was saying earlier, sometimes I've said this in a couple of videos about BykSki QC, and this is another one of those. So you can see here, this is the radiator bracket. As I'm installing the 480 on here, the screws don't line up. It's on one side only, and you can actually tell on the radiator itself it's a little bit uneven. The holes, they're not. It's something about the frame of the radiator. So you can see that I'm able to get up to this hole at the very best, and by this one it's completely off. And it's not the bracket, because I've taken the bracket and tried it on other radiators, like the other BykSki one I have here, and it works fine. And it also works on other 480s that I have. And the distance between the holes are correct. I measured them with the caliper, but this radiator, the holes are not manufactured correctly or whatever it is. So this one was really hard to get in because it's off by like 0.5 millimeter, and this one's just off completely. I don't know if you can see it on the camera, but it's just completely off. So that one's not going to be able to go in on this radiator. What I can say is they probably, these holes aren't going to be exactly perfect on every single radiator. So what they could have done was they could have made it just a bigger hole and then give you a washer. Speaking of which, I'll get to in a second. Make the hole a little bit bigger than just a screw. So then, you can have an option of getting it through. And these are M3 screws that I'm using here. If this is M4, it might not even fit through the hole. And some radiators use M4. So it would make sense to enlarge the actual radiator hole. In addition to that, if you're buying this thing, keep in mind that ideally you want radiators with M3 thread, and you want, or I think 632 might be small enough to go through here. But ideally, you also want to have screws available, because this is about 5 millimeters thick, right? And most radiators don't come with screws that are like 8 millimeter for you to pass through something like this, because most case panels are not this thick. Okay, so I have my own screws, but this thing does not come with any radiator screws for you to think about, and the BykSki radiators do not come with screws to accommodate for such a thing. So these are kind of oversights at the price point, but especially this is just a really bad oversight. But with that said, let's keep going. So what you're looking at here is the finished product. You'll notice that the motherboard has changed, simply because I originally wasn't planning to do this along in this video, but I figured I might as well, since this is a test bench. I've replaced the Z890 Extreme that was there with the Pro WS-TRX50 Sage. This is running the latest 9000 series Threadripper. This is a 9985WX Pro, which means it has more PCIe lanes and can support much more RAM than the regular Threadripper. This GPU did launch today, although I've had this one for a little bit, and I had a vendor locked one a little longer than that, but which I tried to run outside, but that's a whole nother story. With that said, something I didn't notice earlier is that in Chinese, in that right under where it says BykSki, it actually does say test bench, water cooling test bench in Chinese. I don't know if you can hear it, but that pump is running really loud, and you probably see the alarm flashing. Now, what does that alarm mean? Normally, for you guys that aren't aware, BykSki sells these flow meters, and on the flow meter, if you have the direction wrong or the propeller has an issue, you get the alarm. Now, obviously, in this setup, it's attached to the pump. It's no matter how it's going to come out, it's going to come out in the right direction, right? It might go into the block wrong, but overall, it's predetermined it's not like there's a flow in a certain direction and I'm putting that detector on the wrong side of it. Now, it is actually flowing in the right direction from the pump out to the CPU block. Now, everything's in the right flow direction. But there's obviously something wrong with that impeller. Now, same can go for the bottom one, which I found to be also somewhat iffy on that DDC. It's not plugged anything right now because ideally this is meant to be a 2-loop setup, right? So the top will be your CPU, at least for me, and the bottom will be a GPU, at least for me. So overall, I did run into several other issues of putting this together. One, they did not have enough screws to put the entire thing together. There were no PSU screws because the PSU bracket is 5mm thick, 5 to 6mm thick. You need your own kind of 632 screws that are long enough. They did not include enough screws to even mount the radiator brackets. Now, one more thing about the radiator brackets. If I take the 360 one here, you'll notice that the holes for the radiator screw, this is about 3.25 millimeters. All right. So if you're using a radiator with, say, an M4 screw, then you're going to have to tap those out. You're going to have to drill those out some more. The BykSki radiators I'm using are actually M3 space radiator screws. So there's no issue with that, but there's literally no tolerance almost for that to come through. And that's just an oversight. So there's a lot of oversights, right? Like I said earlier, I was missing the PCI bracket, missing screws. The bottom base wasn't correct out the factory, so I had to grind that down. And on top of all of that, this pump design here, the way they have it designed, they really should have, there's no point with the whole flow meter that's not accurate. That flow meter is never accurate. Even the regular one, it's just not accurate. It's not like the one from Aqua Comparator where it's actually accurate. What they should have done is give you a manual control for the pump. That would have made sense, because this does not make sense. Because the pump still uses a PWM header, which then you have to connect to the motherboard. Or ideally, you're going to use an Aquaero, and then run everything off the Aquaero, right? That's the other option. And, I'm using a worst case scenario here, using a board with a 64-core CPU that requires 2 8-pin, a 24-pin, a 6-pin, and an 8-pin just to power the CPU, right? So cable management is, I did the best I could, but if you look at the back, it's not going to be amazing. It's a test bench, but at least having some cable tied down positions would have been nice. I understand it's smooth aluminum and they don't want to really, clunk it up, but make some extra holes where I can screw in a cable management, right? Like thread some extra holes. They didn't do any of that. So I can show you guys the back in a second here. This is the back. As you can see, it is a mess. There are, like I was saying earlier, if they just had some extra holes where I could screw in wire management, right, then I could make this cleaner. But they didn't do that. So granted, I have a worst case scenario with this many wires just powering a CPU. You can tell it's still, I guess it doesn't really matter since it's a test bench. But, everybody likes to have somewhat of a tidiness going on. I just did a lot of zip ties, not too many. But it is sturdy. It is very sturdy. This was wobbling because my table's wobbling because it's on carpet. But other than that, it's not a very heavy-duty base to set the table on. But it is built very sturdy, assuming you have the screws and you can find the extra PCI bracket to put it together that you have on your own. I did reach out to BykSki about the missing parts. And let's just say my rep responded with something that made no sense and unrelated to what I asked. So I'll take it as it's not that important. So one more thing I was saying earlier about the EATX. Once you have EATX board in here, all these grommets and the buttons are just completely useless. Which, I guess, once again, it's a test bench. Having a power button is not, the most important thing, because your motherboard probably has one. All right. But once again, folks that spend $1,500 or $1,600, whatever this is $1,500 or $1,600 for this bench will most likely be using motherboards that are in the $1,000 mark territory. And aside from the Apex and the Tai Chi OC, most of those boards are EATX, and this is just an oversight, one of many. But I mean, I kind of like it because it's unique. But other than that, it's not something I would recommend, simply because I feel like for the price, you could probably build something better on your own. You know, you could just, I mean, if you're not into CADing and designing it, you know, you're not going to be able to do that. But I think there's definitely better options for the price. But the unique part of this one is that you get two 480 loops. I don't know why you would use a 360. It's just wasting space then. You get two separate loops in a kind of a setup that doesn't have too much depth. And as long as you have the table length for it, you can place it somewhere. Most folks, you know, have a table where they bench stuff. This will work, but definitely the bubbles, like I was saying, is going to be one of the considerations that's going to be a little bit difficult. So you definitely want to use high quality high quality QDCs once you get the bubbles out. So otherwise, you're going to be hearing that loud pump nonstop. And obviously, mount Aqua Computer Aquero somewhere in the back or something like that. With that said, let's move on to some of the Threadripper fun that some of you might have come to this video to watch, and we'll see how that goes. Quick look at the Threadripper system here that is running on the BykSki bench. This is the brand new Threadripper 9000 series. This is a pro version of the 64 core. I have it running on an Asus WSTRX50 Sage. This is not the new one. I will have the new one coming, so I will show you guys that when it comes. You're probably wondering, why are you running a pro processor not on the 90WX? Well, reason being is I do have that board, but it is being used by another system right now. So I will get another one and then run this on there, obviously. But with that said, let's just quickly take a look at Cinebench. It's always fun to look at, especially when you have 64 cores and 128 threads. This is running on PBO. So you know, it's not completely stock out the box. One thing with the 9000 series is the improved memory support. It is now 6400 supported base versus I think 5600 on the 7000 series. On the 7000 series, I did have some issues with one of the chips I had. I had three of them. One of them did have issues running memory at 6000 for some reason, but there also was an updated BIOS across multiple manufacturers on let's say mid-June. I kind of improved that memory support. But right out the box here on this Asus board with the June 13th update, I have no issues at all. And you can see how fast Cinebench is running at this. It's a little bit warm in this room right now, but you can see here, if I can see my temp sensor here, if I scroll down. See, but all my cores are within line, right? Nothing's overheating. I actually do have some thermal headroom to push it some more. But you can see here, I'm drawing maximum 614. Oh, there we go. 600 plus watts on the CPU alone. And let's see, where is my temp sensor? All right. So my T sensor is at 33 degrees. It is about 30 degrees ambient in this room right now. It's a warm day in Northeast. So the loop is 3 degrees over ambient on load on a 4080, which not 40 on a 480 millimeter radiator that's 60 millimeters thick. It's 60. I think it's 60. Actually, you know what? That might be a 40 millimeter thick radiator. I have to double check. But obviously, you know, temps are within line, and I'm getting good boost clocks. Okay, but I did run this previously, and I got, I think, like 134,000 something points, which is very high. But obviously, this is not, you know, Cinebench is one use case, but obviously for a lot of rendering apps, you can use GPUs to render faster than your CPU would. But having this high core count does benefit for some applications, which I'll go into just an example for a second. Not the best example, but one example. Obviously, for my use case, it's not going to be for this. It's actually going to be for some certain AI workloads that are going to be running alone 12.8. So this is actually going to be a workstation product for me. If those of you that are interested in HDET setups, I would not recommend you buy the 64 core. I would recommend you buying the 32 core. Simply aside from the cost, it's actually probably scales a lot better with most of the apps you're using, like Premiere, Resolve, etc. And at the same time, going with the 50 rather than the 90 class board. So you don't need 8 DIMM slots. Memory is probably one of the most expensive things on this platform. I think if you were to buy the 1 terabyte RDIMM kit, I think it's 13,000. So in the scheme of things, the chip, which is this one's 8,000, it's actually pretty cheap compared to the rest of the platform costs, storage, memory, etc. So if you're running 256, 128 gigabytes, that's much more in the affordable range of 1,000 to maybe 2,000. Definitely, the standard non-pro is good enough for you because you don't need that memory support. And unless you are in a very particular situation where you have the need for more than the, I think, 80 PCIe lanes on a non-pro, then maybe you need to step to pro. But a lot of the non-pro boards also don't have the right layout for you to use multiple GPUs to be taking advantage of that. So you also have to keep that in mind. I will go over that a little bit more once I get the new Sage in, because at that point I'll have all 3 Sages from Asus, which I'll be honest, they're the only ones that make a WRX 90 outside of like Super Micro, outside of the 90 chipset. I think Super Micro has them, obviously, and obviously the ones made for like Dell and Lenovo and stuff like that. And I don't know if MSI or anything or it's even bothered with the 90 chipset. I think they only have the 50 chipset, which is why I'm just going to show you guys the Asus ones. But you can see this is still going. This is going to go for a while. I can put in a little corner on this video just a faster version of the previous one I did. But with that said, let's move on to one application example that can use this many cores, and we'll take a look from there. Here's one of the applications I use a lot. It's part of my, I guess, PC modding and also hobby style stuff. It's Fusion 360. Fusion 360, not a lot of people see. That's the thing about a lot of reviews when they cover CPUs, they don't really cover CADing programs, especially when it scales with core count. This is not one of the apps that's particularly known for scaling with cores, but it does use all cores. But it also kind of balances that between clock speed. And one of the things, aside from general smoothness and when you go into the manufacturer tab, the time it takes to process, but Fusion does have a render. Now, unfortunately, Fusion Render does not utilize your GPU for whatever reason it may be. I think it's because they want to sell cloud credits, so you can render it in the cloud, and that's how they make money. But if I were to just bring up Task Manager here, you can see that if I go to the right here, this, if you come over here to CPU, yes, I do not have the biggest memory kit on this. This is simply just because I'm testing this. But obviously, but if you're buying Threadripper, I suggest you have more than 64 gigabytes. But with that said, let's just take a quick look. All right, so if I were to start rendering in Canvas here, you'll see that I normally like to put it to final. This is, you see the iteration count based on the time here, and you can see that I am actually using every core at 100%. How does this compare to, say, something like a 9950X3D? I actually did that. I just rendered this in a certain position the same way on both, and it was like 100, almost 200 seconds versus 800 seconds for the same iteration count. I actually put on the bottom here, I'll put the 2 that are running, and the difference here is gigantic, how fast it can get to something, just as an example. So this is one example of an app that does somewhat scale with core count. And I don't know about the other 3D apps, but maybe not so much for SketchUp. But for other things, like if you were to come to, I'm just going to stop this. So if you were to come to things like simulation, this is another one of those things where the core count's going to really come into play here. But yes, so that is one example. For this, if you don't worry, this was actually the build I did for the TT case mod for Computex. But other than that, let's look at one more thing, which I think everybody might be interested in, is just how well this thing can gain. So I'm just going to quickly run the Wukong benchmark to show you guys. And in the corner of that benchmark while I was running, I'm going to put the 9950X3D version. So another more mainstream processor that does have gaming capabilities. Benchmark. I'll show you guys the settings real quick. I'm using settings that the same ones I did on the 9950X3D that I tested with, just to do a comparison. Frame generation is on. All this is on simply because without frame gen, this is going to run like total butt. But it is using the GPU fully, so you don't have to worry about that. We'll run the benchmark just, real quick. see, hold on, contact here. Okay, so let's just run the benchmark and we'll take a look. I can say that this is running at 4K. I think if you're using this type of product, you're gaming at 4K. You're not gaming at 1080p, okay? If you are doing some gaming with your Threadripper, you most likely have other tasks that require you to have a monitor that has more desktop resolution than just 1440p. Most professional apps, benefit from having a higher resolution, right? You can see, I'm maintaining pretty high FPS. I did run this already once, so I can tell you in comparison to my 9950X3D, there was almost no difference at all. You do get a good amount of cache on this as well. Obviously not as much on the X3D chips, but when you split it down by CCD, it's not as much as, say, like the 9800X3D. But nonetheless, it is definitely something you can game on. I'll show you guys the end result from the previous run in comparison to the result on the... Actually, you know what? Let's just let this run through, and then I'll show you put up a screen grab of the result from the 9950X3D. Both of these are running 5090 Astrals, so there should be same GPU, clocked to exactly the same, both running DDR5 as 6000, right? I think the same timings too, actually. But nonetheless, it's definitely a platform you can still use to game if that sort of thing. But yes, so let's just wrap up. So while this is wrapping up, I'm just going to quickly just say the bench. Back to the bench. So the bench still has a lot of bubbles going. It's been a day or two. I don't know if you can hear it through the audio. I'll probably black it out. But yeah, it's at 1600. I never heard back from the rep again about just the issues that I brought up. So I guess I don't know. Maybe the guy just doesn't care, or maybe, since I didn't buy it, they don't care. Whatever it may be, with my history of BykSki products, I've always said the fittings are mostly fine. The finish are usually not that great. The blocks lack QC with the finishes, and they often don't have instructions. Actually, they never have instructions. So it's kind of buyer beware, is what I can say. Obviously, if you're just buying fittings, that's really going to work out. But when we're talking about things like the distro cases that are like $1,000, they're actually so expensive because they were shipped from China. I mean, China, when you buy them, like half the price. I think this thing is only $1,000 in China, maybe a little less. But here you go. You can see 140 FPS. Minimum is pretty good, 75. Like I said, I'll put up the screen grab of the 9950S3D. You'll see it's pretty much the same within margin of error. Actually, this might be a little bit better, but that's just within margin of error running it multiple times. But like I was saying with the BykSki bench, it's not something I would ever recommend anyone buy at $1,600. It's cute. It's a cute concept, but in reality, the amount of issues I had, I just don't see why anybody wants to deal with that. If you have patience to deal with customer service, go for it. But, this was just way too many problems, right? Screws, missing parts, all of that. It's just buy something else. All right. Well, thanks for watching. Next video is going to be a little more interesting on some custom water cooling things. Maybe I could show it. But eventually, for those of you interested in Theadripper stuff, I will cover more of the boards, and I'll be picking up the 32 core as well. So I'll just do some comparisons once I pick that up. But once again, thanks for watching. Stay safe and take care.